Thank you so much for joining this free session on how to break down a system design problem. This is an introductory free session which is part of the Algoroq 12-week cohort built to groom senior staff and principal engineers for engineering leadership positions. You can get more details about this cohort by going to algoroq.io. This cohort will have extremely modern and relevant problems like AI agentic systems, system design of AI infrastructure platforms, and AI-powered coding tools. And this entire cohort is about taking your system design skills to the next level. But before you do that, you need to be able to break down a system design problem into smaller parts. And like they say, the only way to eat an elephant is to cut it down into very small parts. So I'm going to show you how to break down a high-level system design problem with ease. Now you're going to walk away from this session having learned some really awesome skills, and this would be a reflection of how this entire cohort is going to be. We're going to tackle an easy problem that everyone can relate with, and that's an e-commerce platform. Now, I'm sure you have used an e-commerce platform before, so it'll be easy for you to follow along. Now, just for clarity, we won't be doing the system design for an e-commerce problem in today's session, as that is part of the cohort. Today, we're just taking the example of an e-commerce platform to learn how to break down a system design problem. You can use the methodology that I will show you in today's session to break down any system from any high-level system design problem that you face in the future. So let's get started. Right now, the problem we are given is the e-commerce system design. So before we can build the system design, we need to break down the e-commerce platform. The first thing that you would do ideally, whenever you get a system design problem, is to first break down functional and non-functional requirements. Okay. So in the functional requirements, these are the things that your software or your platform definitely needs. Non-functional requirements are the things that support it. So let me list all of these down and you'll understand really well what I'm trying to say. So in the functional requirements these are basically the features that your software will have. Okay. So the first feature that I would want to have is obviously registration. So users want to register, they then want to log in, right? All of that stuff, password management, all of that comes under users registration. So I'm just going to go ahead and write user registration. So that's my feature number one. So what's a great feature number two would be that once they have logged in, they would want to then browse the catalog of the products. So browse and search. This would be a great second feature. Once they have browsed and searched the product, they would want to ideally find out more about the product. So they'll click on the product and they'll go to the details page. So it'll be the product details page. Once you look at the product details, the person would probably want to buy it. So he'll add it to the cart first, and then maybe he'll also check out the product. So he'll buy the product. When he checks out, he's basically making a payment. So payment is a functionality. So that'll be integrated. So you'll be integrating a payment gateway. So the next one would be orders. So once you've made the payment, this creates an order in the platform that the platform owners or the company that's running the platform now has to fulfill. And then you have the admin, or everything that the admin can do, which is mostly around product management. All right. So all of these are the functional requirements. Now for the non-functional requirements, let's break that down as well. So for the non-functional requirements, we are going to have the first non-functional requirement as performance. Now these are, like I mentioned, these are not the features in your software. These are the things that support the software. So the first thing is performance, which means that the pages will load very fast. There will be low latency during search, and the checkout process will be very fast as well. So that is performance. Okay, and if we have this, that means it's great for business. If people are able to load pages faster, they're able to check out faster, more orders, that's just more money for the platform, and the platform is doing well, right? That's the metric that they're probably following. Then you have scalability. So the whole point of an e-commerce platform is to get as many people as possible to purchase from the e-commerce platform. So that's why you want it to be as scalable as possible, so that no matter if there are 100 users today, 1,000 users tomorrow, 10,000 the day after, or there's a special event like Christmas or New Year's, and then there are suddenly 1 million users, the platform should be able to handle that. It should not start breaking. So that's the scalability part. Right. So what I'm trying to say here is, in the functional requirements, even if you have all the features in your software, but they don't work well, they're not performant, they're not scalable, it doesn't matter, then the platform is still failing. So that's what you want to keep in mind when you're designing the non-functional requirements. The third thing is security. Now, security has everything from privacy to what the users are buying, who's buying what, and the whole website being HTTPS, obviously data being encrypted, because you don't want somebody to just download all the products with a simple SQL injection attack or something like that, right? So you want to have a basic level of security. It also includes compliance. So people are making payments on the platform, so you need compliance of different sorts. Then the next thing I have is availability. If the platform is not available, that means it's not working right now. People want to buy stuff and it's not working. That's a bit of a problem, right? Because then if it's not available, that means that nobody's able to purchase something, or or not even able to look at the products. So that's a big problem. So we want high availability. That means a very high uptime, like 99.9% uptime is what we'll aim at. The next thing is observability. We've built all these features, we have all these users, we have people buying products on our platform. So that's why we want to track them. We want to track with the help of logging, monitoring, alerting, right? We want to check if the system is working or not. So observability indirectly helps us with availability, right? And if there's a security breach, then that can be caught in observability. So all of these are kind of linked. And also, if the platform is not scalable, it's struggling, you will see that in your observability. You'll see that in your logs, in your server logs. So that's functional and non-functional requirements. So by now you've learned the most basic step, which is breaking down a system design problem into functional and non-functional requirements. And I haven't introduced myself yet to you because I wanted to get started with the session ASAP. But you might be wondering who I am, and I want to take a few minutes to do just that. Well, I'm Akhil, the founder at Armur AI, which is an LLM-powered cybersecurity tooling company. We've built tools for automated pen testing, automated code security scanning. We have great clients, great products, and great investors backing us. We've been covered by hundreds of magazines and news publications, some of which are listed on our website. Before building Armur AI, I was running a tech consulting firm, and we had clients like Honda, Philips, and Hitachi, and we were trusted to build end-to-end complex softwares for them. While running the consulting firm, I built two products, Dominate AI and Remote Teams, that were not as successful. So I've had my fair share of successes and failures in building products and technologies. Apart from all this, I'm an online technical educator. I have 50,000 students on my YouTube. I have 3 advanced and highly successful courses with the LinkedIn Learning platform and a Udemy course as well. 200,000 engineers follow me combined on all these platforms. I'll be the main instructor at Algoroq, which is a platform where we train senior engineers to be more effective in the real world by helping them understand advanced concepts in system design. And I have an extremely rich experience in building things. I'm in the right position to lead this cohort as an industry veteran. And that's actually our philosophy. We basically want to groom senior staff and principal engineers for leadership positions, and this can only happen if the trainers are industry-led veterans and not academic teachers. And this is why this cohort is better than any course you can buy on the same topic from Stanford or MIT, because they will be more expensive, they won't be live sessions, and they will be extremely academic in nature. Whereas Algoroq is hands-on, and we're teaching real-world system design. Now, if you've had some experience in the industry, let's say about 5 to 7 years, you know that to move up, the main thing you need to do is understanding systems from end to end. And that's the only way to move to an engineering leadership position, because companies need leaders that have a holistic understanding of the system that they're building. Coding, cloud work, security, etc. can be done by the rest of the team, but systems understanding is expected from the leader themselves. This not only prepares you for interviews, but also prepares you for the daily challenges that you need to face after you get the job. Now let's get back to our e-commerce system design problem breakdown session. And I'll tell you more about the cohort, like what we learn, timelines, pricing, once we cover a few more topics. Now, when you've done the functional, non-functional list, you would still feel like you don't still have the exact list of all the features in the platform. Now, when you have to design a system, you want to know how many possible features there could be. Now, you don't have to get extremely detailed, like you don't have to have hundreds of features, but somewhere around 10 to 15 is a good sweet spot. And that can lead to a more comprehensive system design. So even though we created a functional and non-functional requirements list, we're still not there yet, right? So there's one technique that I use that can help us get there, which is called as the visible flow mapping, which is you're following the user and the user's journey throughout the platform, and then you're noting down all the things that the user does. Now, when you note down all the things that the user does, then automatically we can get the list of features from that, okay, that we need to build, I mean. So let's go ahead and do that. So we know that the first thing the user will do is register. So that's the first thing he does. What does he do after that? After that, he will, and we have discussed this already in the functional requirement, we are going to go beyond that. So after registering, he's going to browse the catalog. All right. Now, when he browses the catalog, he's at the same time, he can also, after registering, he can also add details to his profile. You must have seen, right, when you sign up, when you register, when you log in, the e-commerce platform asks you to add more details like your email address or your phone number or your address where you stay, right? So that checkout becomes easier at the end. So we are registering, we're browsing catalog, we're adding details to his profile. And the next thing we can have is when he's browsing, he's also going to search and filter. Okay. Apart from that, once he's done that, he's going to view product details. And once he's looked at the product details, right? This up until now, we are kind of in the territory of where we were when we were mapping out the functional requirements list. But now things start to get a bit more interesting. We are going to, now after he fills in the product, he looks at the product details. There's one thing that he can do that we have not considered yet, right? He can add the product to a wish list. We had not thought of this before. Now only when you're going through the user's journey and what all the user does, can you think of such details. Okay, and the next thing you can do is you can add the product to cart. And this we had obviously thought about earlier. We had also thought about checkout. Okay. Now after checkout, what can the user do? He can also, obviously he makes a payment after checkout. So he will make a payment. And then after payment, he receives some communication from email or SMS. SMS communication is what he receives. So let me move out all the other things. So that's something that he'll get, the email and SMS. The next thing that he can get is the order, right? After he's made the payment, the order gets placed. That's the main thing that happens. Then you can track the order. The user can track the order, and also an invoice gets generated for the user. So these are all the things that the user does on the platform. So let me take you through it again. He is going to register, he's going to browse the catalog, he's going to add details to his profile, he's going to search and filter the products. He's going to look at the product details, he's going to add products to his wish list. He has a cart, he has checkout, he has payment, he has external communication like email, SMS, he has orders, tracking, and invoicing. So he has all these things. Now, this kind of starts giving us a complete picture of what the user does on the platform, and that's why this will help us determine what the remaining features would look like. Apart from this, we are also going to look at something called as invisible flows. Okay, so now we've done all the things that the user can see, like all the things that are visible to him. But then there are some things that are not visible to him, not visible to the user. And those are called as invisible flows. So what are those invisible flows? Let me take you through it. These are mostly the things that the admin team does, or the DevOps team does, some of these things, and many more. So let's actually go through it. So the first thing in the invisible flow would be admin dashboard. Okay, admin dashboard for managing vendors and products. Now this we're considering to be a multi-vendor platform. And apart from the admin dashboard, we'll also have the ability to manage, the vendors can manage categories, okay, and tags and discounts. Then the admin can also manage reviews. And the admin can also get access to analytics and reporting. So this was from the perspective of the admin. Now there are some things that the vendor can also do. Okay, let me first move this to the side. Okay, so this is the admin dashboard, categories, tags, discounts, managing reviews, analytics and reporting. Something that the vendor will do, and that is vendor registration. And uploading products and product details. And details of those products. And then we have a complete inventory management system where the inventory gets deducted. Inventory gets deducted every time a new purchase is made. So these are all the invisible things that are happening behind the scenes that the user does not know about. Now you have the visible flows and the invisible flows. From this, we can actually get our list of all of our components. So let's switch to that. Let's see what it looks like. So I've made it just a little bit more legible, and we can look at the visible flow properly. So the user registers, browses product catalog. He can add data to profile. He can search and filter for products, view product details, wish list, save for later. He can add products to cart, check out, make payment, email and message communication. He can place the order, track the order, invoice can be generated, right? And in the invisible flow, the admin dashboard is there for vendor and user management. You can manage categories, tags, discounts, and coupons. The admin does all of that. Managing the reviews on the platform, analytics and reporting. And the vendor is able to register and manage their products, upload products and product details, and inventory gets deducted every time. So this is basically inventory management system. Now when you look at all of this till now, like functional requirements, visible flow, and invisible flow, you get essentially the components list, which is exactly what we want. So what all is there in our components? And basically the system design is going to be a reflection of all these components. We'll have to plan for all these. So registration and login, admin CRUD, management CRUD, product catalog and details. These are all the different components or modules in the system. Now all of these could be inside a monolith architecture, or these could be independent microservices, or you can group together a few of these functionalities to form one microservice. Okay, so that's something we'll talk about after some time. But right now we have all of these components like coupon and offers, payment gateways, reviews, inventory, external communication, wish lists, search and filters, orders management, logging, monitoring, order tracking, localization, accessibility. So all of these things, these are in our components list. Now, the next thing we want to do is we want to estimate the traffic that's coming to our platform. So we have daily active users, which are 1 million daily active users on our platform. At any point of time, what will be the peak concurrent users that can be possible? So I'm saying that 5% of my daily active users
which is 50,000, would be peak concurrent users. And anytime a user comes to the platform, how much time does he spend on the platform? Let's say 8 minutes. So this estimation exercise is something that you would do. So I usually do traffic estimation and capacity estimation. You do this for ensuring that you and the interviewer are on the same page. Now, one thing that is important is, like, whenever you're doing this functional, non-functional requirements part, right? That's the place where you want to interact with the interviewer and understand if you're on the right track. So I would highly recommend you talk to the interviewer, and especially when you're doing the non-functional requirements, you check with them that, hey, I'm going to prioritize performance, scalability, security, all of these things. Is that fine with you? In this order is what I'm going to be going for. So you'll say, no, I'm not fine with that, or I'm not fine with this. And similarly, for when you come to traffic estimation part, right? So you're about 15 to 20 minutes into the 45-minute round, the system design round, like 15 minutes mostly into it. So you are estimating the traffic right now. Okay, so you would then check with the interviewer that I'm considering 1 million daily active users. That's a scale that I'm going for. Is that fine? He'll say, all right, or he'll say, no, that's too small or too large. You can go for a smaller scale, or you can go for a larger scale. And then you have 5% of DAO, which is 50,000, is the peak concurrent users. And what is the average user time per session? We discussed that's 8 minutes. And how many pages did the user visit? So definitely he's going to look at multiple products. He's probably going to go to the cart. So I would say, let's say 7 pages he goes to. And out of all the activity that he's doing, all of the activity that the users are doing on the platform, how many people actually check out, right? So that's not a lot of people. So I would say that only 2% of the daily active users, all the people who come to the platform in one day, only 2% of those actually end up buying something. So that's also a high estimate. Probably this number actually would be less than 1%, but let's be optimistic. Let's consider 2% of daily active users. So that's 20,000 orders per day is what we're considering. And I think we've already discussed this, which is average pages per session. And what are the number of API calls that will happen per page? So every single page that the user visits, which is 7 pages, every single page will have 5 API calls, like product, price, card, all of these API calls. And page views total. So 1 million users are there in total, which is our daily active users. And each user in one session is going through 7 pages. So that'll be about 7 million page views per day. And so how many API calls is that? So that's 7 million pages. Okay. And then we consider that 5 would be the API calls per page. So that's like 7 million into 5 API calls is equal to 35 million API calls per day. So that's our traffic estimation. Now we want to go for capacity estimation. So user events, search, clicks, and etc. So these are, so we want to check out the capacity, like how many servers are required, how many, let's say, search nodes are required, for the APIs, how many servers are required. And so that's the data that we want to get to. And those are the things that are in bold. That's what we want to get to. But to be able to get to that, we need some more data. For example, how many user events are there? So I'm saying that 7 to 10 million logs per day are being generated. That's 10 to 20 GB per day. So right. So now with capacity estimation, we want to be mindful about the GBs or the PBs, the TBs, like how much data is being generated. And depending on that, we'll have our servers or our databases to handle that kind of data. How many orders? We calculated in the previous step, which is 20,000 orders. So that I'm considering to be 1 to 2 GB per day, which is structured data, right? Orders are structured. Product updates. So 100,000 updates to the stock, pricing, etc. are happening on the products. And images, that's 5 to 10 terabytes per month images of the products. So let's assume that one API server instance can handle 500 requests per second with auto scaling, and peak queries per second would be around 4,000. So how many API instances do we need? How many servers do you need? So that's the actual real calculation that we want. So that's 4,000 peak queries per second divided by 500, which is each API server can handle 500 requests per second. So that's 8 servers are required. Well, I'm going to keep plus 2 servers for buffer. That's 10 total. Now, this is a great, so all of these small things that you notice here, those are the edge that you bring to the system design round, right? Which is that adding 2 for buffer. Now, this shows that you're thinking a little beyond the system design problem, and you're thinking for scale, and you're thinking for failure, right? And that's what makes you a better system designer. Now let's assume 5 to 10 queries per second per user for search or autocomplete queries, and peak would be 20,000 search queries per minute. So that's around 330 queries per second. And each Elasticsearch node can handle 100 queries per second. So we need around 4 to 6 Elasticsearch nodes with some replicas included, because we want to handle 330 queries per second. So even with some replicas, we'll get 4 to 6 ES nodes, 64 GB RAM each. That's the amount of memory required to run one stable Elasticsearch node. So that's our capacity estimation. And by now, you have gone through many things like functional requirements, non-functional requirements, visible flows, invisible flows, components list, right? Traffic estimation and capacity estimation. By now, you are in a strong place to create your system design. And actually, you can go ahead and start building the system design. But we're going to go a bit, little beyond that. We're going to go a little beyond that, and I'll show you what kind of exercises actually take place when we're building a system in the real world and not just for a system design interview. So we'll go a little beyond that. We'll go through a few more things before you're free to go start and building your own system design.
All right, by now you know how visible and invisible flows can lead to your components list, and you can use this later in system design process. We also estimated the traffic and capacity required to run our e-commerce platform. And this is the perfect time for me to inform you about all the topics we'll be covering in our cohort. Like I mentioned earlier, unlike other courses or cohorts, this cohort is going to take you through extremely modern problems that are relevant in 2025, like agentic systems, AI infrastructure, and AI-powered applications. So this is a 12-week cohort starting on the 1st of June 2025. There will be live interactive sessions every week, as well as lots of content to read. We start with a bang in the first week itself by looking at the system design for 5 different systems, including the e-commerce platform. And we'll be using the exact methodology we are learning today to do this. In the second week, we go to the low level and we build the system design for a payment gateway like Stripe. And that'll require us to understand atomicity, idempotency, and security in detail. In the third week, we tackle a very modern problem: AI-powered code editors like Cursor, Windsurf, Lovable. These are highly common these days, and breaking down the system design for these prepares you for a future where you'll have to architect and build AI-driven applications. In the fourth week, we learn about architecting data-intensive systems like social media platforms and understand how to enhance availability with concepts such as blast radius isolation using cellular architecture. We enter the fifth week by building geocentric systems like Google Maps, Uber, and food delivery applications, where we'll dig down deeper into ETI calculations, proximity search, spatial sharding, and so on. Then in the sixth week, we tackle one of the most complex problems in system design, working with real-time systems. And we'll be building stock market trading platforms that have millions of real-time orders every second. In the seventh week, we start with a very exciting problem: video streaming platforms. This not only requires us to understand microservices and real-time systems extremely well, but also requires us to deep dive into latency and bandwidth management, along with specific techniques like adaptive bitrate sampling. The eighth week is all about building a complete AI system like OpenAI or Anthropic, where we have to worry about building data pipelines, training models, deploying them, and optimizing inference times. This is highly relevant in 2025 and gives you a behind-the-scene understanding of top AI infrastructure companies. By the ninth week, we're ready for advanced topics like distributed systems, and we'll learn everything about distributed loggers. We'll take algorithm deep dives with B trees, B plus trees, LSM trees, SS tables, Bloom filters, trie-based matching, and we'll take things further with understanding how to reduce false positives, delta encoding, and Levenstein distance. In the 10th week, we build upon all the heavy concepts we learned in the previous week by building the system design for a distributed file storage system. And we take it further with erasure coding and Reed-Solomon algorithm. By week 11, we're ready to learn about AI agentic systems. We learn about orchestration frameworks, model context protocol, and advanced concepts like multi-LLM collaborative agent workflows, and reasoning chains and recovery paths as well. Week 12 is going to be intensive with the system design of a decentralized messaging system, where we get a deeper understanding of decentralized systems, and we learn about Diffie-Hellman and double ratchet algorithms. We also focus a lot on security with advanced concepts like elliptic curves and key exchanges with ED 25519. We also learn how to effectively manage decentralized systems programmatically with libp2p, federated networks, relay nodes, and gossip protocols. As you may have deduced by looking at the contents of the cohort, it's going to be a super intense bootcamp where you won't be the same person as you were when you enrolled in the program. You'll have a new way of thinking, a deeper understanding of the systems, a more modern approach to system design, and a holistic approach in architecting complex problems. There will also be many bonus sessions on leading teams, working with cross-functional teams, engineering best practices and processes that will help you truly become an engineering leader. This is the cohort you have to be a part of if you're truly looking to upskill in 2025. Now let's go back to our session on breaking down system design problems and learn about some planning exercises next. And then after some time, we'll talk about pricing and the next steps for the cohort.
So this is what I was talking about. It's a planning exercise to help us prioritize what to build and what not to build. So because let's say you're sitting in a team and you're planning to build a product, then everybody says, oh, this is important, this is important, this is also important. But then if you start or if you end up building everything, then you don't meet your deadlines or you don't even ship anything. So how do you ship on time? How do you build something at least? That's what's done with the help of Moscow, which is must have, should have, could have, and won't have. So what's in our must have? So this is something that I filled in already. So in our must have, obviously we'll have to have registration and login, browsing and searching products, product detail page, adding to cart and checkout, payment integration, order placement and tracking, admin panel for product management, inventory updates and stock checks. What are some? So these are my functional things that I must have. Some non-functional things that I must have. Definitely, I need a HTTPS. I can't launch a website without it, and a little bit of basic security. I need fast response time. Basic security basically means with authentication, with user data, right? All of that stuff. Fast response time from the APIs, okay? And uptime. I need very good uptime, because if in an e-commerce platform, especially if the uptime is low, it affects business because people are actually going to buy from the platform. And I need, this is, I don't think that's very important, but I've kind of added that in must have, mobile responsive UI, because in 2025, people buy a lot on mobile. Like for example, Amazon or any other website that you're buying from, you would buy from mobile. So I would think, like in my opinion, everything else is more important. But then I've added this just as an add-on. But all of this is in my must-have. Then I have my should-haves. So functional stuff, wish list, save for later, right? Now what I'm saying is that to ship the MVP, like the minimum viable product, I need at least this much. And if I have time, and if I have the resources, time and money, then I'm going to go ahead and work on my should-haves, which is wish list, save for later, coupon and discount system, cancel, return, order workflow, and product reviews and ratings. All of this is important, but then not as important as the stuff that's required for the people to look at products and buy them. So this is should have, like email and SMS notifications after they buy the product. Guest checkout, they don't have to log in to buy something. Role-based access for admins, like the admin should not have access to everything. Maybe a new intern has joined the team. He should have access to only a few of the things. Some non-functional things, observability. So logging, metrics and alerts, basic rate limiting and bot protection, CDN for static content like images, CSS and JS. So those are my should have. And then now, once I've built my must have and my should have, and I have time, resources and money pending with me, and I have built the MVP, I've launched in the market, I'm getting good response, I can now work on the could have. So I'm working on the loyalty program, gift cards. This is to keep the people buying more, social login, so that it just makes it easier for them to log in and buy more, seller vendor onboarding, right? So everything that you're seeing here helps people buy more stuff. So real-time chat with support, voice search or AI-based recommendations, and some non-functional things like multilingual and multi-currency support. As you can see, all of these things are not as important as obviously the should have and must have stuff. So we also have SEO optimization, offline mode for PWA, advanced A/B testing infra. And then I have my won't have, things that I'm not going to have, which is my AR, VR product previews. Like these days, a lot of e-commerce platforms, they have AR and VR product review. You can test out a sunglass on your face when you switch on the camera. So I don't think we need that. Drone-based delivery integration, definitely don't need that. Blockchain-based loyalty payments, definitely don't need that. Personal AI shopping assistant, we don't need that now. Headless CMS style infra, okay, we don't need any of these. So this is what I won't have, at least in the beginning. And then I have some stretch goals, right? So if I'm done with my must have, should have, could have, I can go for some stretch goals. Stretch goals are things that, we can go for if we have a lot of time remaining, or if some people in the team are free, if they get free early, they can work on the stretch goals like AI powered product recommendations, natural language search, inventory aware dynamic pricing. So if you have less inventory, you can, price it more, the product. That means there's more demand for it. And then you have multi-tenant vendor marketplace, you have AI chat assistant for support, automated return and refund workflow, gamification, and rewards engine. So all of these things are my stretch goals. Now this is what a real world practice, like a real world actual planning exercise would look like. So there will be people in the team, right? CTOs and engineering directors and architects, all of these guys sitting down, product managers as well, TPMs as well, sitting down and going through this planning exercise to see what's important and what's not important before proceeding. Then you have some key considerations. So what this means is all the things that kind of like they are, at least these two are part of our non-functional requirements, but these are considerations that we need to think about. Okay, so for example, and there's this huge list of key considerations that we'll go over in the cohort once you join it. So there are these like about 30-40 different considerations that you want to think of, and you can pick only a handful. You can pick like 5, for example, for your product. So I'm going to pick up data integrity. I'm going to pick up security, fault tolerance, scalability, and availability, these things. Availability and scalability we've already thought of when we were talking about our non-functional flows. Fault tolerance. So I don't want my system to go down easily, and also I want it to recover easily when it goes down. So that's fault tolerance. So I'm going to have retry mechanisms, circuit breakers, fallbacks, all of those things. Security, we've talked about security already. Data integrity. So I'm going to use idempotent APIs for payments and checkout. Okay. And as part of the cohort, we're going to design a payment gateway, and that's where we'll be talking about asset transactions and idempotent APIs, eventual consistency, all of this, if you haven't learned about these before.
All right, so now that you've learned about planning exercises like Moscow, stretch goals, and the various considerations, I hope you have a slightly better understanding of what happens when teams sit down together to build complex systems. Now is the perfect time for us to discuss pricing of the cohort. There are 3 plans, and I recommend going for the middle plan, which is called the Pro plan, because in the basic plan, you don't get access to any of the live sessions. And that's where most of the value in the cohort is. This Pro plan is originally for $1,200, but for all early birds, right now, the pricing is just $999. It's a 12 weeks intensive live sessions program, and the pricing is highly justified considering the insane amount of value that you will get. Now, we want to support you, and this is why we also have an EMI plan available where you can pay in 3 simple installments. The first one of $399, which needs to be paid before the cohort starts. The next one of $300 after 3 weeks, and the last one of $300 after 3 more weeks. I highly recommend you join the program if you're looking to upskill. The payment QR code has been flashing on the screen since the beginning of this session. You can feel free to scan it and make the payment. And if you need any assistance with the EMI installment plan, you can get in touch with our team on akhil@algoroq.io. When you scan the QR code, it will take you to a payment page and you can make the payment there. And you will then receive some onboarding materials like links to articles and blogs that will help prepare you for the upcoming cohort. Also, you need to join the WhatsApp group that can be joined by anyone. But once you've made the payment, you will be added to an exclusive group where only the participants in the cohort will be added. And you can interact with like-minded people and grow and learn with them. I promise I won't bore you with any more information about the cohort now. You already have the payment QR code and the website algoroq.io where you can get more information whenever you need. And if you need any assistance with the payment plans or any EMI installment support, you can get in touch with our team at akhil@algoroq.io. So let's finish our session.
Now let's talk about bottlenecks, or the things that can happen that can lead to the system not scaling that well, or the things that can appear at scale which create problems. So bottlenecks happen at multiple layers. So for example, it could happen at the database layer where you can have slow joins. So let's say you have microservices for products, reviews, and pricing, or different, at least, databases for these. And when you want to run some query, you want to get information from all these 3 databases, it's going to take time. So that's a slow join problem. And if you have lack of indexing, that will lead to inefficient queries, right? So let's say at scale, if you don't have indexing done, it's going to lead to a lot of problems. You have blocking and contention on inventory or cart tables. So because people are adding something to cart and before they check out, what to do with the inventory? Do you have to reduce the inventory or should you not reduce the inventory? That's a whole problem, right? And then single write MasterDB can't handle high order volume. So if you have flash sales, suddenly there are 10 million or new orders, then it's difficult to handle that if there's only single write MasterDB. Then we can also have bottlenecks in the search system. So if you have very high queries per second from autocomplete and category filtering, that'll be a problem. You can, because we only considered about 4 to 6 different servers, but what if there are more queries? Then we won't be able to handle that, right? What if the product catalog indexing is large, which slows down performance? So what if you have lots of products, or each product has a lot of details? That's going to slow down performance. And what if your Elasticsearch is not tuned really well? So that's also can lead to problems in the search system. The other thing is product image. So we don't realize, but images actually take up a lot of space. They are in MBs sometimes, and there are multiple images for each product. So product image needs a CDN, and if it's not cached, it can lead to slow load time. And bandwidth heavy pages. So it leads to bandwidth heavy pages, because let's say the thumbnails are not optimized and you're displaying like lots of products in one page, they're not optimized, the thumbnails can lead to slow response from the server. Then you have some admin panel actions which can also slow down, which is, these are like very notorious, right? Bulk upload. So you're bulk uploading a lot of products in a particular format that the database accepts, CSV imports or discount changes, and this can lock or slow down the DB. Lock the DB because you're adding new products, people are buying it, so there has to be a lock that first adds the product and then people are able to read them or buy them to ensure data integrity. So this can slow down the platform. And then there can be poor separation of admin and user traffic. So a company like Amazon also has a lot of admin traffic. There's a lot of employees that they have. Then some trade-offs. So now these are the things that we've been discussing since Moscow stretch goals and all of these things. They're kind of optional. Like you can do functional, non-functional, visible flow, invisible flow, components list, estimation, and you can start with system design, like I said. But if you go beyond, right, if you go with Moscow, stretch goals, key considerations, bottlenecks, trade-offs, architecture decisions, you are just going to the next level. And in a 45-minute round, if you can do all of this in 30 minutes, which is very, very doable, by the way, if you can do all of this in 30 minutes, that's great, because you still get 15 minutes to design the system. Now, one question would be that, oh, if I don't leave the last 15 minutes for questions from the interviewer, isn't that a bad thing? And the answer to that is that the interviewer would be asking you questions all throughout. Like he won't just keep waiting for you to finish the system design and then ask you questions. And that's a very healthy thing, like when you keep answering questions on the go. And if you think, you always have the timer on your side. If you think that you won't finish in time, then you can skip a few parts. But I'm just giving you the best practices or what all things to cover. And once you've done all of this, right, once you've done this entire exercise, it'll be very, very easy for you to design the system, as we'll see as part of the cohort. Okay, so trade-offs. So speed versus accuracy. So do you want speed or do you want accuracy in searching and filtering? Okay, do you want on-demand pricing as the user is searching for it, or do you want it to be pre-computed? Pre-computed saves time. On-demand does not save time, but it's accurate sometimes. It's storage efficient because you don't have to store it also. And then user experience versus security. So you can keep optimizing for security, but that really affects the user experience. Like you've seen in bank applications, they optimize for security, not user experience. And that can happen with an e-commerce platform, and people don't want that to happen in an e-commerce platform. Now, some architecture decisions. Do you want to go with monolith or do you want to go with microservices? So what we're saying is we'll start with the modular monolith and then we'll move to microservices when scaling independently. Now, how do you actually break down a modular monolith into microservices with decomposition? That's something we're going to see as part of the cohort. So trade-offs: monolith is easier to build initially, but harder to scale later. Microservices scale better, but increase operational complexity a lot, and also increase a lot of cost because you need multiple different servers now, and a lot of communication between those microservices. Now, do you want to have synchronous or asynchronous communication? You can use synchronous REST APIs or gRPC, or you can have an async messaging system like Kafka or SQS or auto processing and all that. So synchronous is simpler but highly tightly coupled. Async is more resilient but requires event tracking and eventual consistency, right? So maybe you know about microservices and async communication. Maybe you've seen my free 6-hour video on YouTube on microservices. If you've not, do check it out. This gets covered in a lot of detail there. Then you have stateful versus stateless services. So you can make all front-end facing services stateless, and you can store user sessions and cards in Redis. Redis is a in-memory storage. Trade-offs. So if it's stateless, it's more scalable, but stateful requires careful session and failover management. Okay. And observability. So we're working with Prometheus and Grafana for metrics. We're working with Loki and Elk for logs and Jaeger for tracing. So the trade-off is you get more visibility because you have more logging softwares and more monitoring apps and tools, and you get better debugging, but it adds a lot of infrastructure costs and lots of complexity because you have to actually go ahead and add tags and events in your front end and back end, and then you have to monitor all of those in your logging environment and your monitoring environment, and then there can be discrepancies as well. So this is the entire exercise. Now, once you've done this exercise, it's very, very simple to go ahead and build a system design. Like I mentioned, we're not handling system design in this particular session. If you've made it this far, it means you're serious about leveling up and not just learning theory, but building real engineering judgment. At Algoroq, we don't just teach system design, we train you to think like an engineering leader, to design systems that scale, survive failure, and lead teams. The next 12 weeks will be intense, hands-on, and incredibly rewarding. You'll walk away with deep confidence, clarity, and a portfolio of design skills that top engineers are expected to have. So if you're ready to stop watching and start building, apply now. Spots are limited and we start soon. Let's go from engineer to architect together. And this brings us to the end of the session. I hope you enjoyed learning how to break down a system design problem effectively. I hope you enroll in the program, and I'll see you in the cohort.